Now let's discuss stack operations. In this video, we will talk about what stack really is, how stack works, and how do we move the values into a stack and how do we restore the values from a stack. Generally speaking, stack is a memory region within the program or a process. This part of the memory gets allocated when a process is created. We use stack for restoring or temporary data such as local variables of some function. As the stack moves from the high memory location to the low memory location. When we say this, a high memory location or a high memory address refers to the memory address that is numerically larger compared to the others within the same memory range. Memory addresses are typically represented as the hexadecimal numbers, and the higher addresses are those with the larger values. In many computer architectures, including Intel and ARM, the stack starts at the higher memory address and grows downward toward the lower memory address. When the items are popped from the stack pointer moves upward and toward the higher memory address. Now let's look at the stack operations that are pop and push. Push and pop instructions allow us to interact with the stack. The push instruction saves the register into the stack and decreases the stack pointer and then store the specified register at the new stack location. The pop instruction retrieves the data from the stack into registers. It loads the value from the stack into the specified registers and then increases the stack pointer. As you can see in this example where we are pushing the values of register R1, R2 and R3, they are stored into the stack simultaneously. As you can see, first the value of register 1 is pushed, then the value of register 2 and then the value of register 3. As you can see in the pop instruction, we restore the value from a stack. In this example, we are restoring the value on the top of the stack and storing it into the register R3. Now let's understand this within the CPU later. As you can see, I have already written the code where I have loaded the values into a registers and used the push instructions to load their values into the stack and pop instruction to restore those values. Let's compile and run. As you can see, the first 4 instructions loads the value into corresponding registers. As you can see, after the load instructions, R0, R1, R2 and R3 have gained the values, and after the push instruction, the values from corresponding registers will simultaneously be pushed into the stack. And now to see the pop instruction, the effect of the pop instruction, we will reset the registers. After resetting the registers, the pop instruction here will restore the values into the corresponding registers. As the the value at the top of the stack, that was R3, will be restored into R3. Correspondingly, the next value on the top of this stack was of the R2 will be restored back into the R2, and similarly with the R1 and R0. As you can see, after the pop instruction, we have restored the values into R1, R2, R3 and R0.